tool, nice and smooth, and then just to show you, right now the mask plate is loose. It can be moved very easily, pushed back in. Now we're going to hit change mask again, and now the vacuum system is holding that mask in place so you can't move it out of the machine. It's locked rigidly in place. And that completes the loading of the mask. When you're ready to either load or unload the mask, you press the change mask button. When you want to toggle the mask vacuum off and on, you use the enter button. When you want to select the contact program, you press the select program button. And then you can use the arrow keys to cycle between various contact modes. And for our wafer, we've selected vacuum contact. If you use the edit parameter button, you can adjust the exposure time. And again, the exposure time is adjusted using the up and down arrows. What we want to use for our exposure time is a time of 6 seconds. Once you finish your selection, you press the button again and you're out of edit parameters mode. One of the quirks of the Carl Seuss is that whenever the tool is started, it initially comes up in what's called backside alignment mode. This tool can align to features on the back of the wafer or to features on the front of the wafer. What we want to use is we want to use topside alignment or microscope mode. You can see that the backside alignment microscope mode button has a green light lit. The green light is at the top, indicating that it's in backside alignment mode. In order to do our work, we need to change to microscope mode, and we push that button. And now the green light goes out. That tells us that the thing on the bottom, microscope, is selected. And the next thing we need to do is we need to move the microscope into position so that we can find alignment marks on the mask. And to do that, we use F1, which is the function key for lowering the microscope. And you'll notice that after pressing F1, the F1 button and the enter button are flashing. To actually get the microscope to move, we press enter, and the microscope lowers into position. What we do in the mask aligner is that we align the wafer with respect to the mask. There are typically alignment marks on the mask. And we have, as you can see, a split field microscope. So there is microscope. There's a split field microscope. So we have left and right objectives that are looking at the mask. And we can adjust the position of those objectives in and out using some knobs on the side that will make the objectives move in and out, so we can change the spacing of the objectives. We can change the orientation of the microscope using a knob up here so that we can take out any orientation or theta errors. We have a knob that allows us to do a coarse focus of the microscope. And so when we turn that knob, we either move the microscope up or we move it down and we change the focus. And using buttons on the panel, we can actually move the microscope from side to side. We can put it in fast mode and move fast, or in slow mode and move more slowly. So our first objective, having loaded the mask, is to find the alignment marks on the mask that we want to use to align up to the wafer. Once the mask we found the alignment marks on the mask, the next thing we need to do is we need to position the wafer so that the wafer, its alignment marks, match the ones on the mask. And to move the wafer, we have three additional controls. We have a micrometer on the bottom on the right side that controls the X position or horizontal position of the wafer. We have a micrometer on the left that controls the vertical position of the wafer. And we have another smaller micrometer handle that controls theta, or the orientation of the wafer. So the idea is, first we find the alignment marks on the mask. We get a nice crisp image of that. Then we load the wafer and we try to find the alignment marks on the wafer and make them match up with the alignment marks on the mask. The first task with the mask loaded is to try to find alignment marks on the mask. And to do that, we're going to move the microscope around a little bit and see if we can find a mark. And son of a gun, there's a mark. Now you'll notice that the mark is showing up right now. We've got one mark on the right side of the monitor. This is set up as a split field display so that the right side of the monitor is showing what was on the right microscope objective and the left side shows what's on the left microscope objective. And now we're going to try to find a mark on the other side. And well, there's a mark kind of on the other side, and what we're seeing is that these marks are sort of at different, if you like, elevations, different Y values. That's telling us that the orientation of the microscope isn't correct. So we're going to adjust that orientation and using the knob that we showed before. And the top of that box that's around that alignment mark should become basically horizontal. And when we get close to horizontal, if we move side to side, we should see marks on either side, and we do. Now all we have to do is change the distance between the objectives to make it so that we can see one mark on one side and one mark on the other side. Now that we've done this, we're going to do a coarse focus of our image using the knob that was on top of the microscope. Try and get reasonable looking images on both sides. And then we have some fine focusing knobs that we can use to fine tune it. We've got one pair of knobs for when the microscope is set to be looking at the top substrate, which is how the microscope is set right now, left and right. And then we've got another pair of knobs below that for when we're looking at the bottom substrate. And we can fine-tune the focus until those images are about as good as we can make them. And at this point, we're ready to load our wafer. Before you load your wafer, it's a very good idea to center the stage that the wafer rests on, the wafer chuck. We are going to do this by adjusting the 3 micrometers that were described earlier. The X and Y micrometers have a full scale span of 20 millimeters, so we set those on 10 to be at the middle of their travel. And the theta micrometer we just adjust until it's centered in accordance with the little visual aid that we've got. Now the other thing we're going to do is we're going to slide the tray that holds the wafer chuck out. No, just slide it out. Slide it out. And we're going to make sure that the index mark on the wafer chuck is lined up very nicely with the little pin that it's supposed to be aligned